Hi everyone, welcome to today's tutorial. So in this tutorial we're going to be discussing how you can find the indefinite integrals and how you can check them using differentiation. So if maybe you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button down there, and then also don't forget to click on the notification button. And if you have any questions or you need tuitions in mathematics, feel free to contact me on any of these lines on the screen. And if you want to join the group in which I post all these tutorial videos, you can still contact me on any of these lines on the screen, and then I'll make sure that I'll add you to the group. Okay, so let's quickly do the question. So the question is telling us to find the indefinite integral and check the result by differentiation. So the first question we have is the integral of x plus 7. So we have so the first one is which is the integral of x plus 7. The integral of x plus 7, and then we're integrating this with respect to x. So we're going to integrate the independent terms, meaning we're going to have the integral of x then plus the integral of 7. So I'm going to say dx, meaning with respect to x, even this one with respect to x. So when we integrate the first part here, the integration of x is just found by adding 1 to the power of x and then dividing by the new power. What I mean is that if you have x, then you've been told to integrate this. So from to this power of x, we're going to add 1, and then we're going to divide the whole expression by the same new power, which is 1 plus 1. So this will give us x squared over 2. So when we integrate x, we're going to get x squared over 2. And then when you integrate 7, which is just a constant, it's also going to have, so initially 7 is just the same as 7x to the power 0. So when you add 1 to 0, you're going to get 7x to the power 1, which is just the same as 7x. So we have 7x. But since these are not definite integrals, meaning we don't have limits here and there, we don't have limits, so meaning we add a constant c. So if we have limits, I'm going to show you in the next video how you deal with the limits. But in this case, we don't have limits. That's why they are called indefinite integrals. So you just integrate them directly and then add a constant c there. So this is how you do the integration. But how do you prove if your answer is correct or wrong? So let us try to find the derivative of this expression. So the derivative of this expression, the first part here is we have 1 over 2x squared plus 7x plus c. So when you differentiate the first part, we're going to multiply this the power with the coefficient of x. So we're going to have 2 times half there, which is just going to give us 2 over 2, and then we have x. And then from these 2, we're going to subtract 1. So we're going to say 2 minus 1. Then we say plus 7. We have x to the power 1 minus 1. And then this 1 times 7 to still give us 7. So the derivative of a constant is always 0. So this and that gives us 1. So I'm just going to remain with x, because 2 minus 1 will just give us x. Then plus 1 minus 1 is 0. X to the power 0, the answer is 1. 1 times 7, we are going to have 7 as the answer. So x plus 7 is the solution to this expression. So when you differentiate this expression, we're getting x plus 7, which is exactly what we have there. So this shows us that our solution is correct. So this is how you integrate, and then this is how you differentiate. Okay, so let's quickly move on to the next question. So integration is straightforward. That's why sometimes it's called anti-differentiation, because you just do the opposite things that we do in differentiation. Okay, so we have 13 minus x. So the integral of 13 minus x, we're integrating this with respect to x. So dx means with respect to x. So when we integrate 13, we're going to have 13x. When we integrate negative x, we're going to have x squared over 2. So this is how you do the integration. Because it's an indefinite integral, you don't have to forget to add a c. So if you want to prove whether this is correct or wrong, you can differentiate it. How do you differentiate 13? So when you differentiate 13x, you are getting 13. Differentiate this expression there, you are getting negative 2 over 2x. And then differentiate the constant, you are getting a 0. So 2 over 2 will give us 1. So we have 13 minus x as the solution, which is exactly what we have there. So all these questions are very simple and straightforward. So it's not something that we should even take time to finish. So let me pick a different question, something that is slightly different from what we've solved. So integrating this one, okay, let me also integrate this one. So we have x to the power 5 plus 1. So the integral of this with respect to x will give us what? So integrating x to the power 5 will give us x to the power 6. We divide by the new power, which is 6, then plus integrating 1 will give us x, then plus c. So this is how you do the integration. You can prove this by differentiating it. You get back to that expression. So let's quickly also integrate this one. So the integral of 8x to the power 3 minus 9x squared plus 4 with respect to x. So integrating this with respect to x, the first one there are going to have 8x, this power 3 to, plus 1, we're getting 4, then divide by the new power. Yeah, so this 4 divided by the new power, which is 4, then we say minus, we have 9, then this is a squared, so this squared plus 1, we get 3, so we have x to the power 3 divided by the new power, which is 3, then we have plus 4, then x plus c. So the first one here will give us 4 into 8, this will be 2x to the power 4, 3 into 9 will be 3, and then we have x to the power 3, then we have 4x plus c. So this is how you do the integration. It's very simple. Let's quickly move on to the next one. So let me also do this one, and then I'll pick random questions from this side. So we have the integral. So the questions that I'm going to leave, make sure that you can do them and try to send the solutions over. And then I'll check if at all the solution is correct or wrong. So plus 2x plus 1. Okay. So this is what we have. We're integrating this with respect to x. So integrating this part, we're going to add 1 to the power. So 3 over 2 plus 1, we're getting, so this will be x. 3 over 2 plus 1, this will give us 5 over 2. We divide everything by 5 over 2. Then this one will give us plus 2x squared over 2. We divide by the new power there. And then we have, when you integrate 1, you're getting x, then plus the constant c. So we have, this can also be written as 2 over 5x to the power 5 over 2. Then we have 2 over 2, the answer is 1, so we just have x squared. Then we have plus x plus c. Okay, so this is the solution. Let me pick another question. So I'm just going to pick a random question, because there are a lot of questions here. We can't manage to solve them all in just a few minutes. Okay, let me go to this one. So we have the integral of 1 over x 5 dx. So when you integrate this, you're going to get with respect to x. So before you can integrate, if you want, you can write it as x to the power negative 5 dx. So when you integrate this part, we add 1 to the power, So when you add 1 to negative 5, you are going to have x to the power negative 4, then divide by the new power, which is negative 4, then plus the constant c. So you are going to get, this can also be written as negative 1 over 4 x to the power 4 plus c. So I've just taken this down. I've just taken it to this format. Okay, so the same thing I've done here, that's what you do there. Okay, so we also have this one. Let's see how we can do it. So all these questions are straightforward. So I'm picking random questions. So we have the integral of x plus 6, everything divided by the root of x dx. So when you are integrating this one, even before you integrate, if you want, you can say, we know that 1 over the root of x can also be written as 1 over x to the power half, which can also be written as x to the power negative half. So I can write this expression as x plus 6, and then we write it as x to the power negative half. So this expression is what I've written in this format. Then we say with respect to x, so this will now be equal to, when you multiply x to the power negative half times x, you're going to get, so since we're multiplying numbers with the same base, meaning we have x as a base, even there we have x as a base, so meaning we add to the power. So when you add negative half and half, rather when you add 1 and negative half, you get x to the power half. Then when you multiply 6 times x to the power negative half, you're going to have 6x to the power negative half. Then we have dx. So when you integrate x to the power half, you add 1 to the power there, which will give you x to the power. When you add 1 to the power, you're going to get x to the power 3 over 2. Then you divide by the new power, which is 3 over 2. Then you say plus 6. When you add 1 to negative half, you are going to get half. When you add 1 to negative half, you're going to get half. So this will be x to the power half. And then we divide this by the new power. This will be half as a new power, and then we say plus c. So this, if we divide this by that, we're going to get 2 over 3. Then x to the power 3 over 2. Then we say plus. When you divide this by that, we're going to get 2 over 1. We have 6 x to the power half. So plus c. So this can also be written as 2 root x in brackets to the power 3, then everything over 3, then plus 2 times 6, that would be a 12 root x, then plus a c this side. You're supposed to add a c that side. Alright, so this is how you do the integrations. Very simple. So to some questions here I will not be I will not be solving. Let me just be telling you what to do, and then those that need me to solve, I'll solve them. So we have this one, you can solve it because we know the root of x is just the same as x to the power half. This one, you can change it. You can write it as 1 over 2 times x to the power negative half, this one. Then you you integrate. So this part here is also straightforward. So when you say the root of x squared, the cube root of x squared, this is just the same as x. This is just the same as x to the power a half. And then when you say the cube root, it's just the same as 1 over 3. So you can write this as x to the power 1 over 2 times 3, that is 6. It's just the same as the integral of that with respect to x. So this is exactly what you're supposed to do. The fourth root, you just change here, you just put 1 over 4 there, then there you're putting a 3 for this question. Then this part, which is 1, is straightforward. So when you integrate 1, you just get x. I've solved this one. This one is straightforward. You solve it in a similar way I solved this. So now I've solved it. For this one, you can just divide. You can say the integral of x over 4, x to the power 4 over x to the power 4. The answer is 1. And then we have negative 3 over x to the power 2 and x to the power 4 there. When they divide, you're going to get x to the power 2. And then, so the other one that you're going to have is this one. You're going to have 5 over x to the power 4. So this one is now straightforward. You can now just integrate it. Yeah, so you can just integrate this directly. So the integral of 1 is just x, the integral of this part. Or before you integrate, first you can simplify the expression. Let's simplify it further. So this can be written as the integral of 1. Then we can also write this as 3x to the power negative 2, then plus 5x to the power negative 4. Then say with respect to x. So integrating this one is now straightforward. So the integral of x, the integral of 1 there is x. The integral of this part, you just multiply the power, which is negative 2, to the coefficient of x, which is negative 3 there, which will give you positive 6. Then you say, sorry for that, I started differentiating. So integrating this one, we add 1 to the power. So we add 1 to negative 2, and this will be negative 2 plus 1. This will be x to the power negative 1. And then we divide by the new power. So this is what we're going to have. Then we say plus 5. Then we say x to the power negative 4 plus 1. This will be negative 3. Then we divide by the new power, which is negative 3. So say plus c, which is the constant. So what you just need to do here is to divide everything direct. So we have x there, negative 1 and negative 3 will give us positive 3. Then we have x to the power negative 1. Then we also have this part, which will be negative 5 over 3, x to the power negative 3, then plus c. So you can just take this part as the denominator there, and also this part as the denominator, so that the powers become positive. What I mean is, this expression can also be written as x plus 3 over x, then minus 5 over 3 x to the power 3, then plus c. Alright, so this is exactly what you're supposed to do. Alright, so let's quickly also pick one question from these questions. Okay, so these are straightforward questions. Let me pick another question. Okay, so we have, okay, let me get one trigonometric function. Let me get this one here. So we have the integral of 5 cos x, then plus 4 sine x, then we have dx this side. So integrating this is straightforward. So we know to say the derivative of sine x. So the derivative of sine x is cos x. Then the derivative of cos x is negative sine x. So meaning when integrating, where there's cos x, we're going to put sine x. Where there's sine x, we'll put negative cos x. So what this means is that when you integrate the first part here, we're going to get when you integrate the first part, you are going to, when you integrate cos here, you're going to get sine. So the first part here will give us 5 sine x. Then when you integrate sine x, you are going to get negative cos x, but there is a 4 this side, so we're going to add a 4. So this is what you are going to get as your integral. Okay, so since these are indefinite integrals, meaning you don't have to forget to add a c. Okay, so this is exactly what you're supposed to do. Alright, so thank you very much for watching today's tutorial. If you have any questions, feel free to contact me on any of these lines on the screen, and don't forget to subscribe to the channel. My name is Harmtedy. Shalom, shalom.